know. None of them, they don't know. Nothing they know. Just there is completely, their brain is empty, a normal one. Okay, just they know that what they are seeing, just they'll observe. Every day they'll learn something. The 6 months baby to 1 year old baby, in between 6 months to 1 year, before 6 months, they will not even learn anything. Slowly after 6 months, they'll start observing something. They'll observe the world. Some person has weighed in terms of what is the dress, what is the color. They'll try to recognize. So before 6 months, if you go to the baby and if you touch the baby for 10 times also, they'll not recognize you. 11th time also, they'll not recognize, unless only mother they'll recognize. Apart from mother, they will not recognize any one of them also. They can't recognize. They can't even recognize. That is the situation of the 6 months baby, before to 6 months. After 6 months, now slowly they'll start recognizing the father or someone who is coming daily and whom they are watching daily. Okay, whom they are watching daily, every day they are going to observe. First day they will not observe anything. Okay, first 6 months. Later 6 months, they are starting observation. After observations, they will go to new persons. Now, for example, if I bring a 1-year-old baby to this class, and if I say I have shown one of the student, and if I say that to go to that person, means they'll go, no, right? They'll not go. Even 1 year also, they'll not go. So they have to observe multiple times. Now, just understand how this baby is learning the things. Just tell me how this baby will learn. Just understand the scenario. There is 6 months to 1 year baby, and first time they are seeing others, they are learning new things. Slowly they are observing, slowly they are recognizing, slowly they are learning one by one. The step-by-step feeding, whatever the step-by-step feeding is there, you are going to feed them. Feed them means you are going to give some inputs to them. You are going to share some inputs. Arey, he is your uncle. Arey, uncle, something will say like this. Go to uncle, go to near to uncle. Something will say like this. And the baby, initially they may cry, they may not be interested, they may be interested, some people. So it depends. Now you are going to share the inputs. You are going to step-by-step feeding means nothing but you are going to give the inputs. And within these inputs, by taking the inputs from the known person, whoever the known person has given the inputs, from the known person, it is taking the inputs, and in the brain, it is processing. They are processing in their brain something. They don't know what is meant by uncle also, they don't know. Go to also, they don't know. They are calling you also, they don't know. Nothing they know. Just based on your hand movement or eyes movement or based on your expressions, they are understanding something. With their whatever the basic understanding they are doing, according to that, they are working. They don't know anything. Sometimes lip synchronization due to the lip movement. Sometimes some words they may recollect whatever the things was done multiple times. Something. Okay, based on the input, it is processing, and based on the processing, finally it is going to give the output. Okay, so finally the baby is going to react. For example, for 1 year baby, you are saying, "Hey, he is your uncle, Ra. Go to that person na. He is calling you na." Like this, if you say smoothly also, they will listen na. Some people may listen, some people may not listen. Some babies will understand and they'll go initially itself. On day one itself, they'll go. Some babies, though you say very close relative also, they'll not go. So they're processing in their brain. Something they are processing in the brain, and finally they are giving the reaction outside. Now this input plus processing plus output, whatever the intelligence they are doing, the entire intelligence in their body, inside the body, this intelligence will be done by the brain. Brain will do all these things. Your ears are the, whatever the ears are there, ears and eyes, the baby eyes and ears are the input. It is listening and it is observing. These two are the input, and these two input will be sent to the brain, and the brain will process. After the brain processing, the brain will tell to the baby what to do, how to react, whether to raise the hand, whether to raise the leg, or whether to cry, something. So what it is going to do the output, that is the final one. Now here the brain is going to process that one. Now the scientist has got a doubt. hey, this baby doesn't know anything. First time I'm saying amma, or in Telugu, in English, a mother, something. Now, if you are saying something like this, it is able to understand how the scientist has got a doubt. In brain, something was happening. I'm saying orally, and the baby is listening through ears, and it is sending the information to the brain. And in the brain, something was doing the processing, and finally, it is getting registered there. Now, entire this process, can't we create artificially? Can't we create artificially? Means there'll be some location. In this location, I will send some input, some information I will send, and here I will make some formulas. I will write inside this one some formulas. These formulas are nothing but processing formulas. Some formulas they have written, and these formulas I will process. And after the formula, whatever the output I have got, that is the output. So they have created by observing this one as it is. So now, simply to say, in our human brain, the input is, you are listening now, right? Everyone are listening, online students and offline students. Everyone are listening to their ears and they're observing the board. Whatever I'm writing, they're observing. This is the input you're sharing to your brain. You're collecting from me the input, and through your ears, through your eyes, you are sending that information into your brain now, as of now. In your brain, you are trying to understand this one. From your perspective, you are trying to understand. You are thinking, you may think your relatives only, one baby. If I say one baby, means you may visualize with one of the baby also. Some people will visualize. Some people may not visualize. So they will do according to them processing. And finally, they are going to store this example, whatever the example I'm going to say, that they are trying to store in their brain. They are doing some processing. After this processing, now the whatever the things are important, if you feel that you are going to write in the notes. Your hand is the output. Finally, what you are going to write with your hand is the output. Whichever you feel important, that one you are going. Guys, everyone can hear me, online students? Sorry, due to small technical issue, the internet was disconnected. It is clear right now? Done. So this is our human brain. Whatever the processing was done, this is in the human brain. Okay, this process is done in the human brain. So where your eyes and ears are collecting the information, in your brain it is processing, and finally your hand is writing the output. You are going to write the sentences. So this is our normal human brain. Now the same thing in the artificial intelligence. Intelligence means, what is the intelligence means? Processing the information is called as intelligence. If you are not processing any information, you are not doing anything special. If I ask you to go and bring that particular mobile phone, means simply you are going and bringing, means you are not processing anything now. What I am saying, you are doing that work. If you are able to think of yourself, you are processing some information, whatever the based on the given information, it is able to process, then it is called as artificial intelligence. Now, artificial intelligence also will consist of 3 steps. First step is called as input. Second step is called as processing. And third step is called as output. Any computer will have 3 only now. A normal computer also will have the same 3. Input or processing, output, CPU, output. Everyone knows. Now here, this artificial intelligence, how this is going to have with respect to input means your data, whatever the structured data is there now. This structured data, for example, just I'm going to recall that whatever we have discussed with respect to the TV, radio, newspaper example, and I'm trying to recolor the linear regression. Okay, there where I'm having the TV, radio, newspaper, and sales. This is the one which we have worked for the linear regression, multiple linear regression, where the equation is equal to y is equal to beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus b. Now, from here we are going to calculate the beta 1, beta 2, beta 3 such a way that the sum of the squares of error should be minimum. This should be minimum. You have to identify these 3 values along with the beta naught. Total 4 values you have to identify. These 4 values, finally the equation, whatever the equation you are calculating, this equation should give the sum of the squares of errors as the minimum. That is OLS technique, ordinary least square technique. So for any regression algorithm, the sum of the squares of error should be minimum. Why sum of the squares of error should be minimum is our ultimate goal is RMSE should be minimum. For RMSE should be minimum is MSE should be minimum. MSE should be minimum is SSE should be minimum. If SSE is minimum, automatically MSE will be minimum. MSE is minimum is RMSE will be minimum, because numerator is minimum is automatically denominator is constant. There is no use of denominator. Numerator, if you are reducing the numerator means automatically this one will be reduced, because this is nothing but this one only, right? So this one is reduced. Y minus y hat whole square you are reducing. Automatically this will be reduced because denominator is not going to change. If this is constant, automatically square root also will be less. If this is less means automatically this will also be less. Our ultimate is RMSE only. But instead of focusing on RMSE, we are focusing on the SSE. Now we require the SSE as the minimum. For getting the SSE as minimum, we are going to solve this one by applying the d by dx. D by dx at x is equal to 0. And from that, we are going to make a mathematical calculations of beta 1, beta 2, beta 3, and beta naught separately. And we have seen how to calculate also, right? We have done that one in the multiple linear regression. Mathematically, we have done. Theoretically, we have done. And manually, everything we have done manually also, everything. Now, whatever you have done here, the same to same, once again, in the artificial intelligence also, we are going to do the same to same as it is. No difference. No difference. Here, what I'm going to do means, I'm going to take in terms of the equation. What is the equation here? Beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus beta naught. This is the equation. Keep this equation separated. This is machine learning. Keep this one separated. In the artificial intelligence, what happens means it is going to take in the 3 neurons. They are called as neurons. Now, why 3 only? Because you are having 3 input variables. 3 input variables are there, so 3 neurons. The first input variable is TV. Second one is radio. Third one is called as newspaper. Sir, what is meant by neuron? Where the work will be done, that is called, that part, that location is called as neuron. Okay, somewhere the location has to be done. The location name it is called as neuron. Now what happens here? We are going to have like this something, and here we are going to calculate this one is W1, W2, W3. And here I'm having with respect to X1, this is X1 variable, this is X2 variable, this is X3 variable. Now what I'm going to do here, calculation. What calculation I'm going to do means W1 X1 plus W2 X2 plus W3 X3 plus B. Same to same. Now here you are calculating beta 1 X1, beta 2 X2, beta 3 X3, beta naught. Where beta 1, beta 2, beta 3 are called as quotient values and beta naught is called as intercept values. Same, but notation they have changed. Instead of beta, they are using W. Instead of beta naught, they are using the B. Notation they have changed. Concept is same. Now what it is going to do? First record. First it will send the first record here. Whatever the value is there, that value will be sent into this. Now here what they are going to do means they are going to assign the weights and B randomly some number. Initially one number they are going to assign. Okay, let me assume the first number as 4, second number 5, third number 6. And beta naught B value as 10. I'm having the equation 4x1 plus 5x2 plus 6x3 plus 10. Okay, now sir, here first record, in the first record whatever the values are there, 3 values are there now. These 3 values you are going to give here and you are going to predict the y hat, some y hat. Second record, again you are going to send the information, again you are going to predict the y hat. Third one y hat, fourth one y hat, like this. All the records you are going to do and you are going to calculate the y hat for each of the record. Now you calculate it. After calculation, now what you are going to do? You are going to calculate sigma of y minus y hat whole square. It will be calculated. For randomly assigned 4, 5, 6 and 10, it calculated the sigma of y minus y hat whole square. Now it will come back and it will modify these values. It will come back and it will modify the values. After modifying the values, now again it will do the calculation. Now it is going to move like that, front and back, front and back, front and back, like this. Multiple times it is going to move. And finally it will identify the best W1, W2, W3 along with the B, which gives the minimum sum of the squares of errors. Here also you are going to calculate beta 1, beta 2, beta 3 and beta naught, which gives the minimum sum of the squares of errors. Here also you are going to do the same. Here also you are going to do the same. Here also you are going to do the same. Ultimate goal is sum of the squares of error should be minimum. Sir, why we have to do this much now? Already in machine learning, simple linear, multiple linear regression is existing now. Then why you are doing an artificial intelligence this much of complicated? Very simple logic. For example, I'm having with respect to 2x plus 5 is equal to 10. Now what is the x value? Everyone will say easily, sir, 2x is equal to, first 2x is equal to 10 minus 5, 2x is equal to 5, x is equal to 5 by 2, which is 2.5. Other than this process, without applying this process, tell me any other process to calculate the x value. Tell me, can anyone tell me other than this one? This one I know, x value is equal to 2.5. Apart, other than this process, without applying this process, tell me how to calculate x is equal to 2.5. Another way. Exactly. You are going to randomly assign the x values. You are going to assign the randomly the x values, and you are going to check between the difference between the LHS versus RHS. And you are trying to reduce that one. So here, let us assume this equation as W. Okay, 2W plus 5, where W is equal to 2.5. This is normal calculation. Now I'm going to try with W is equal to 10. First I'll try with W is equal to 10. Why 10? The right side maximum value is 10 only now. So than that it can't be more. So let us try with the W is equal to 10. Let us start some number. Somewhere we have to start now. You are not interested in 10, 1,000 you take. 10,000 you take, as per your choice. First you start with one number. Here the concept is important. Number is not important. Don't focus on the number. Understand the concept. So I'm writing W is equal to 10. 2 into W plus 5, that is 2 into 10. 2 into 10 plus 5, which is nothing but 25. This is the calculated value. This is the calculated value. What is the actual value? 10 is the actual value. What is the difference between actual versus predicted value? Which is nothing but minus 15. So now what you are going to do? W you are going to try to increase. Instead of decreasing, first you increase. Now you are going to calculate 2 into 11 plus 5, which is nothing but 22 plus 5, 27. And original value is 10 as it is. Now minus 17. Error increased or decreased? Increased. As W increases, error also increasing. Now what you'll understand, oh, we should not increase the W, we have to decrease the W. Now what you are going to do? You are trying to reduce the W. 9. 2 into 9 plus 5, which is nothing but 23. Actual value is 10. Actual value will never change. So the difference was minus 13. Okay, as W decreases, error also decreasing. Now let us try with W is equal to 8. You will try with 8. After 7. After that 6. After that 5. After that 4. After that 3. W is equal to 3. 2 6 are plus 5, which is nothing but 2 3s are 2 3s are 6. 6 plus 5, 11. Original value is 10 and the difference is minus 1. Now W is equal to 2. 2 into 2 plus 5, which is nothing but 9. Original value is 10 plus 1. Okay, my required answer is between this. Now what I'm going to do? 2.1, 2.2, 2.3, 2.4, 2.5. Completely trial and error method. I'm applying the trial and error method. Sir, why is this much of things? Simply calculation is their side. Why you are doing this much? If there is a simple equation, you are going to do the simple calculation. If a complex equations are there, which you can't do the mathematically step by step, in that case, what we are going to do? Trial and error. We have observed the same thing in our competitive exams. In certain questions, we are going to do the step by step process and we'll identify A, B, C, D out of which one is correct. For certain questions, we'll make using the options. First, we'll try option A, option B, option C, option D. For which questions you are going to do like that? For which questions you are going to do like this? Two different ways, right? One is in the competitive exam, maths related questions, anything are there. One way is doing the calculations and getting the value. You have to do the calculation and get the value, and you have to observe this value whether it is in the A or B or C or D, and according to that you are going to make a tick mark. For certain questions, what you are going to do, using the A option, whether it is getting solved or not, using the B option, using the C option, using the D option. In that case, what we are making? Trial and error. Certain cases will be there with respect to normal things, certain cases will be with respect to this one. So for a simple example, machine learning is sufficient. For a complex example, artificial intelligence is going to give the better results. How it will give the better results, sir? Same logic is getting applied now. If both the logics are same, means how better results we'll get? Better results, how you'll get? That is the point in the artificial intelligence that we are going to see now. Now, just I'm writing once again. What is the difference between your MLR versus AN? This model, artificial intelligence, this one is called as perceptron model. This is called as perceptron. Your MLR is equal to perceptron. MLR or simply SLR. SLR or MLR is called as, in artificial intelligence, they are called as perceptron model. Simply they are called as perceptron. Either simple linear regression, multiple linear regression, or logistic regression also. Logistic regression also comes under perceptron only. Okay, before writing something, just observe this one, later you can write, so that it will be dead easy to understand. So in the first, let us start with the simple linear regression. Assume I'm having simple linear regression, where I'm having one input variable X and one output variable Y. Okay, this is the case. The equation is beta 1 X plus beta naught, where I have to calculate the beta 1 and beta naught such a way that the sum of the squares of error should be minimum in the simple linear regression. And coming to the next one, multiple linear regression. Coming to the multiple linear regression, here you are having with respect to more than one input variable, that is x1 and x2 and y. Now in this case, you are going to make an equation called as beta 1 x1 plus beta 2 x2 plus beta naught. You have to calculate the beta 1, beta 2 and beta naught such a way that they give the sum of the squares of errors as the minimum. In this case, now if you go with the logistic regression, what you are going to do? First, you are going to take the x1 and x2 and y, and first you are going to calculate the same beta 1 x1 plus beta 2 x2 plus beta 2 x2 plus beta naught up to here common, and whatever the value you have got, you are going to convert to the probability, that is 1 divided by 1 plus e to the power of minus y. Whatever the y you have got, you are substituting here, and you are going to get the probability as the output. And whatever the probability more than 0.5, it is converted as class 1, less than 0.5 is converted as 0. This is the logistic regression and linear regression which we have done in the machine learning. Same to same as it is. Now perceptron model, where I'm having the input variable x, only one input variable. Once again, I'm considering only one input variable x and y. Don't write simultaneously along with me, guys. Online students and offline, both the students. Anyways, offline they are not writing. Online students, please don't write. Just focus. Okay. Now here, what it is going to do means, here it is going to take two neurons. One neuron is called as input and second one is called as output. And it is going to make a connection between them with W1. Okay, name it as W1. Here, whatever the X data is there, that data you are going to send into this, and in the output neuron, what it is going to do means sigma Wi xi, that is nothing but it is going to calculate W1 x plus b, same to same equation. It is going to calculate the sigma, that is W1 x plus b, where W1 and b values such a way that they should have the sum of the squares of errors should be minimum. Now this one, now I'm having with x1, x2 and y. Now in this case, two input neurons will be 2 and output neuron will be 1 once again. And I'm going to connect between them like this. Now this is W1, this is W2. This is x1 and x2. Means x1 information will be sent into this one, x2 information will be sent into this one. Now x2 will be multiplied with W2, x1 will be multiplied with the W1. So it is going to calculate the W1 x1 plus W2 x2 plus b. And it has to identify the W1, W2 and b in such a way that the sum of the squares of error should be minimum. Now you are having with respect to third one, that is x1, x2 and y. Now same two input neurons, x1 and x2, two input neurons. How many number of columns are there? That many neurons you are going to take. And for that, whatever the beta 1 you are writing here, beta 1 means here you are going to write W1. Here you are writing beta 2 means you are going beta 2 for x2. So for x2 you are writing the W2. And you are going to calculate. Now once again you are going to calculate the same W1 x1 plus W2 x2 plus b, same to same. Once again you are calculating the same to same, and once it is calculated, now you are going to calculate the p value from this, that is same formula. Once again same formula, and the p value is greater than 0.5 means it will be converted as class 1. If it is less than 0.5 means it will be converted as class 0. Sir, what function is getting applied means sigmoid function only. Same function, same sigmoid, no difference. This is called as perceptron model. Our perceptron model is equal to machine learning model. Both are same to same. If you give the same data set for both of them, same answers will be the output also. No difference you'll observe, not even minute difference also you'll observe. if you give the same train test split random state number exactly, means same input data fit on X train, Y train. If you provide the same data, the output will be the same answer. If you change the data, output will change. If you provide the same as is data, you will also get same as is values. There will be no difference. Now, for complex examples, they have increased the dosage. If this is the case, no need to create artificial intelligence. If this is the case, no need to create. But what is the difference between the logistic regression versus random forest or decision tree or boost, all these things? In logistic regression, you are able to classify the data. Then what is the purpose of creating decision tree? Who asked you to create the decision tree? Why you have created random forest algorithm? Why you created the boosting algorithms? All these algorithms, what is the purpose of creation? If one of them is satisfying everything, what is the purpose of creating another one? The another one with respect to the decision tree or with respect to random forest or ADA boost, what is the purpose of creating this? In order to get the betterization of accuracy. The basic algorithms are not giving that much. Initially, they're okay. But if you increase the level of difficulty, they are not able to perform very well. So that is the reason I'm having a large amount of data. Logistic regression will not give the best result. So in that case, we have to go with the decision tree or random forest. So like that same way, perceptron model is not sufficient means you are going to the next level concept is called as neural network. This is called as perceptron model. The next one is called as neural network. Is the logic is clear? Now you can write in the notes. Whatever you have understand, you can write. Now it is neat. Now you can take the photo comparatively when compared to earlier one. Yeah, guys, 100% don't hesitate to take the photos. Absolutely not a problem because yours is official. Online students is unofficial. They are also doing the screenshots. Who knows? Yours is official. It is. I can see you officially. We can't see them. I don't feel. Okay. That is completely depend on you, whether you want to write or whether you want to take. If you take the photo also, no problem after the class, but you write that one. Understand each and every letter and write in the notes. By understanding, right. Sir, how the input will color the information, how processing will be done, how the entire calculations will be done. After that, finally, how the output we are going to get, everything we are going to do step by step. Okay, just I have given you an overview. What my meaning is here, artificial intelligence and machine learning, everything are designed for giving the betterization of the accuracy. So for the given data set, should I apply deep learn? Should I apply this artificial intelligence, or should I apply that machine learning? Means we have to apply both of them. Which gives the maximum accuracy? That one. In the Kaggle computation, if you are having some data set, Titanic data set or some XYZ data set, for that you have to apply even neural network also. Maybe neural network gives the better accuracy. Who knows? None of them knows, right? So we have to try with all of the possibilities. Whatever the possibilities are there, every possibility we have to check. We have to check with perceptron. We have to check with neural networks, all these things. Done, guys? So whether it is with respect to linear regression or whether it is a perceptron model, our ultimate goal is sum of the squares of error should be minimum. For example, in logistic regression, the output is accuracy. We should get the maximum accuracy. For regression algorithms, the error should be minimum. For classification algorithms, the accuracy should be maximum. Accuracy wise. Okay. So for regression algorithms, okay, if you go with the regression algorithms, yes, sir, here what value B contains in W1x plus B? Same. Whatever here beta naught contains, the same B here, whatever the beta naught you are having, the same thing here B. Both are same. Here it is intercept value, here also it is intercept value. Here it is quotient value, here also it is quotient value. No difference. As it is, both are same. One is quotient and one is intercept. Is that clear? Now, Santosh, is your question is clear? The B value is nothing but intercept. Now, here, okay. Now here in the in the artificial intelligence, whatever we are going to do, the step-by-step process. Here, we are having different types of neural networks. Out of first one is called as artificial neural network. We are having different types of neural network, out of which the first neural network is called as artificial neural network. What is the purpose of artificial neural network? Means to apply a regression or classification. Only these two things you can apply. You can't apply clustering, recommendation engines, nothing you can apply. Only classification or regression, any. Supervised machine learning and the machine learning, supervised machine learning techniques. Here in the artificial intelligence, it is artificial neural network. Okay, you can apply either regression or classification. For our regression projects, the ultimate goal of regression should be RMSE should be low or R space should be high. Any one out of this. Ultimate goal of this project, any regression project, the ultimate goal is this one. Okay, finally, the test accuracy or test RMSE. Test RMSE, if you are saying miss, the test RMSE should be the least to least. If you are working on the R square miss, test R square should be the highest. Okay, along with neither overfitted or underfitted. If it is with underfitting, if I get 100% test accuracy also, I don't require that one. Along with the neither overfitted or underfitted, along with having the cross validation score equal to test accuracy, which satisfies the model selection conditions, with that one only I have to require. Now for classification projects, if you go with the classification related projects, for classification related projects, either your accuracy should be high, or with respect to misclassification rate should be low. Either classification should be high, accuracy, or misclassification rate should be low. If misclassification rate is low, means automatically accuracy is high. Both are opposite to each other. Here also both are opposite to each other. Okay, if you are discussing error mode, means error is this both comes under error, these both comes under accuracies. For regression projects, this is errors. For accuracy wise, these are the accuracies. All right. Now here I'm having with respect to the error, whatever the error or whatever I'm having with respect to, here I'm going to focus on, for any regression project, I'll focus on the RMSE should be low. I'll focus on the error should be low. Error is low means automatic accuracy is high. I'll focus my RMSE should be least. While working on the classification projects, I'll work on the misclassification should be least. If the misclassification is least means automatically accuracy will be high. Okay. So now here the artificial neural networks for regression or classification projects only you're going to apply. You can't apply these artificial neural networks for clustering algorithms, recommendation engines, association rules, any other you can't apply. For unsupervised machine learning, you can't apply. Only for supervised machine learning only you can apply. Supervised data, that is labeled data. To be more precise, artificial neural networks can be applied only on the labeled data. Can be applied only on the labeled data. Labeled data means where output variable is available. Where output is available. That is with respect to either regression or classification. Now, first, let us understand artificial neural networks. This is called as neuron. Neuron. Where neuron means it will collect the information or it will process the information. This is called as neuron. Okay, the neuron, it is going to either collect the information. If it is collecting the information, it is called as input neuron. If it is processing the information, it is called as processing neuron. If it is giving output means it is called as output neuron. Whatever the stage it is there, in that stage it is called as accordingly. If it is collecting only, it is not doing anything, just it is collecting the information. For example, some students will be there. They'll collect only the materials. From each of the person, they'll collect the materials and they'll keep in their hard disk. They will not do anything. They'll collect. Their interest is to collect. If they see any new material, immediately first their brain says that collect that one. After collecting, they'll relax. They'll not prepare. I have seen certain people like that. Of course, I am also in that one of the person sometimes. So where we'll collect the information, but we'll not do the processing. Sometimes we'll do the processing. Sometimes we'll give the output. So here the neuron, whatever the neuron is there, so the neuron will be either with respect to input, either it will be processing, either it will be with respect to output. So here I'm having with respect to input neuron, output neuron, and processing neuron. So if I connect them, if I make a connection between the neurons connections is called as neural network. Connections between the neuron is called as neural network, which was created artificially. So it is called as artificial neural network. Okay, sir, why it is called separately? Why you have to write artificially? Artificial normal only na. Generally, they are called as neural networks only. Why you have to write separately the word called as artificial word means in our body also neural network is there. Inside our body also neural network is there and neurons are connected to each other. Inside our body, almost billions of neurons are there, not with one or two. From your ear to the brain, from your leg toes to your brain, from your hand tips to your brain, every part of your body, every single part of your body is connected to your brain. If the brain dead person is there means none of the part will work. Entire body part will not work. Though heartbeat is there also, you can't shake your hand, you can't shake your head, you can't shake your eyes, you can't shake your legs. None of them you can move also. Slightly also you can't move. If the person is in the coma, he will alive. He will be alive only. He will be in alive, he will be in the coma, he will be in ICU or normal, something. But there will be no movement in the body. The body is dead. So brain dead persons means there is no use. Okay, there is no use. They will not have anything. They will not do any kind of processing. No processing, no output. If something is there, if I'm saying something to you and your brain is processing that one, because your brain is active, your brain is processing. If the same information, if I go and say to the brain dead person, coma person, to the coma person, if I say, "Arey, wake up, ra," if I say like this, he'll wake up. No, right? Information is sending through the ears, information is getting, but brain is not processing because the brain is dead now. Brain is not processing. So brain is not processing, so there is no output from the brain. So in the body, completely billions of neurons are connected to each other. In the body also, we are having the neural network inside our human body. This neural network is called as biological neural network. Whatever inside the body, the neural network is there, it is called as biological neurons. They are connected biologically. Okay, so they are called as biological neural networks, which was created by the human. The neural network is called as artificial neural network. It is clear point. Now here deep learning means detailed learning. Basically it is detail. I'm explaining detailedly. Okay, too much of detailness. Now here, so why I'm explaining that much of detailedly with respect to the body, so that you can understand easily step by step, you can digest, because the artificial intelligence is going to play a major role in the future. For that, the basics should be very strong. If the basics are strong, the advanced part is dead easy. For any subject, I believe for any subject, if the basics are very, very strong, means any level we can learn on our own also in the future without depending on anyone. If the basics only not strong, means every time, I'm not able to understand that, because we'll focus on the example now. Will not understand the concept now. In the future, if you're trying to learn any new concept, you'll depend on others. Can you explain this one? Can you explain this one like this? Okay, when the basics are very strong, we don't need to depend on others. Never we can depend on others. Now here, whatever the deep learning means detailed learning. How our brain will process internally, that one is called as deep. Internal process of the brain, how it is going to process. Okay, so here, they are, all of them are connected to each other. Everything are connected to each other. Multiple neurons are connected to each other. Okay, with your hand, you're holding your hands, or if you're seeing with your eyes, or whatever the movements you are doing with your body, every minute movement is sent by the brain. Brain is saying that shake your hand like that, so you are shaking your hand. Brain is saying that observe the board, you are observing. Brain is saying that see the SRK service, you are seeing me. Whatever the brain says, according to that, you are working. You are not working, your eyes are working. Okay, so everything are connected to the brain. So here, multiple neurons are doing internally some processing. That processing was done with a ultimate speed, within a minute seconds, with respect to microseconds. In your body, the every processing is done in microseconds. That is the reason you are not able to observe that one. If it is taking time, then you can observe that one. For example, this best example for this is future. So earlier we are having 2G, 3G, 4G, now 5G. Now, what is the difference between these G's numbers? What is the difference? We are having latency rate. Latency rate means response rate. So now whatever the 5G we are presently are there, it is with respect to 8 milliseconds per 8 milliseconds. We are having with respect to 8 milliseconds. Means whatever the internet speed it is going to give with respect to 8 milliseconds. In the future, we are going to get this one with respect to 1 millisecond. If it decreases to 1 millisecond, if the same thing decreases to 1 millisecond, what happens? Directly the doctor will be in the online. And he will shake his hand, and by using that he will do the surgery. Online surgeries will be there in the future. You don't need to go to the hospital also. In the house only surgeries will be done. The doctor will be in US, the supporting doctors will be here, and the surgeries will be done. I mean, in the operation theater, not in the house, sorry. In the operation theaters. In Indian operation theaters, US doctor will do directly the surgery. With his hand only, directly he will do. That much of technology we are going to see in the future when it is 1 millisecond. If he does now, in that fraction of seconds, something may happen and the person may die also. If it is a complex surgery. If it is a simple surgery, just a bandage means there is no problem. A gap of 1 second also there is no problem. But some surgeries will be there. Within a seconds, milliseconds only we have to react for that things. So in that case, we are going to have like that. So this technology is getting developed. Scientists working on that. In India, Saint company is working on that. In order to make the latency speed to 1 milli per second. Okay, done. Let us keep that one side. That we may get in the next 5 years or 6 years or something. Okay, but they have started the process now itself. Now here, what are the input are there? The input to output, all the things are connected to each other. So this is our human brain. If you do the scanning of our human brain, this is the one. Inside the human brain, you are saying like this now. These are not called as ants. They are called as neurons. Whatever you are having inside, every small thing you are observing, right? Everything are neurons. So it is connected like this. Billions of neurons are there. Okay. Now here we are having a input. All the input neurons are called as input layer. Input neurons, what are the input neurons we are having? All the input neurons is called as input layer. And whatever the output is there, if you are having the output, this is called as output layer. Whatever the neuron is located in the output, that is called as output neuron, and that layer is called as output layer. And in between them, it is going to do the processing. This is called as hidden layer. Now the question would be, sir, how many neurons we are going to select in the input? How many output neurons? How many hidden layer neurons? All these things we'll understand later, one by one. I'll explain. For everything, there is rules are there. For certain, there are no rules are there. Wherever there is no rule, the answer is hyperparameter tuning. Wherever the rule is there, fixed answer. We can't do the hyperparameter tuning. We have to fix. We can't change as per our choice. Wherever there is no rule is there, we have to do the hyperparameter tuning. Right? Now here, we are having with respect to the input neurons. These input neurons are called as input layer, and in between processing neurons where they are going to do the process, and finally in the output neuron, it is going to give the output. And these are connected like this. Everything are connected like this. To every neuron to other neuron. So this layer will be connected to this one only. For example, in my hand, this is my finger. My finger will be connected to this one only, not directly to the brain. Now. This neuron will be connected to the next part of the neuron. Directly it will not connect to the brain neuron. Now. Here in between multiple neurons are there from here to here. This neuron will be connected to the next one. Next neuron will be connected to the next one, next one, next one, next one, like that, finally to the brain. But everything are connected. So input neuron will be connected to the hidden layer. Input will not be directly connected to the output. Adjacent layer, what are the adjacent layer? Next layer is there, that layer only they are going to connect. So it is getting connected to the next layer like this. And all the neurons are connected like this. And finally, you are connected to the output layer. Okay. Now this one, whatever the layer we are having, the output layer and everything. So if you are always the number of input layers are going to be one fixed. Okay. How many number of input layers? Okay. Now you have to write the notes. Number of input layers is equal to number of input layers is equal to 1. It is fixed. No change in this. Number of output layers. How many number of output layers? I'm not discussing about the neurons. Layer. Layer means it consists of multiple neurons. 1 to infinite number of neurons. A layer may consist of 1 to infinite number of neurons, but it is called as layer. Now here, number of output layers are equal to 1. Again, this is also fixed answer every time. Layers will be 1. Now, how many number of hidden layers should be there in between? In between input to between this one, how many should be there? That is 0 to infinite. There is no rule. No rule means automatically hyperparameter tuning. Okay, no rule. If 0 hidden layers are there, then it is called as perceptron model. Perceptron means the input directly will be connected to the output. Earlier you have taken the diagram and some of you have taken the screenshots now, where input is directly connected to the output. In between nothing is there. In that case, if middle hidden layer is not there, then it is called as perceptron model. If number of hidden layers are equal to 0, perfectly it is equal to 0, then it is called as perceptron. If the number of hidden layers is equal to 0, if the number of hidden layers are equal to 1 or 2 layers, if you are having only 1 or 2, something like this, then it is called as artificial neural network, a normal neural network, simple neural network. This is called as neural network. Neural network. Where I'm saying number of hidden layers. If your number of hidden layers is equal to exactly 1, then it is called as perceptron model. If your number of hidden layers is equal to either 1 or 2, any one, either one hidden layer or two hidden layers. If you have either one or two hidden layers, then it is called as neural network. If you are having number of hidden layers, as I've told you, number of hidden layers can be 0 to infinite. If it is more than 2, then it is called as deep neural network. It is considered as deep neural network. Deep neural network. If the number of hidden layers are more than 2, it is considered as deep neural network. Okay. Now, this is layers wise. Now coming to the number of neurons wise. Now let us move on to the neurons. Okay, everyone is clear with this? Please take a note of this. Clearly write in the notes clearly. And I'll explain with multiple examples. Don't worry. Just we are in the starting stage only. I'm in the 10th slide only. Total 90 slides are there. So much of things are there to be discussed. One by one, we'll see. Don't ask your questions now itself. After understanding everything, later you'll understand one by one. I'll explain in the each neuron what happens internally. From there, how it is going to pass the information to other neuron, how that other neuron will collect the information, how it will pass the information to the next one. Everything we'll see. And finally, how we'll get the output also. Every step by step, minute step also we'll observe. Right? Is that clear up to here? Now, number of input neurons. Number of input neurons in input layer. In your input layer, number of input neurons is equal to, how many should be there? Means number of input variables. It should be equal to the number of input variables, which is nothing but your number of columns. Your number of columns in X-train. Whatever you are providing in the X-train, training data, within the trained data, not original data. In the original data, you may drop some of the features, which are useless features, you may drop. Which finally, which you are providing to X-train, that one it is going to consider. That too, that is the order it is going to consider. Order also important here. So that is equal to number of columns in the X-train data. In the X-train, how many columns you are providing, that many number of input neurons you have to take. Now, a number of output neurons. Number of output neurons in output layer. In your output layer, you have to take the number of output neurons. How many you have to take means is equal to 1 if it is a regression or binary classification problem. For regression or binary classification is equal to 1. Is equal to n for multi-class classification problem. Multi-class classification problem n, where n is nothing but number of categories in the output variable. For example, penguin dataset is there. In the penguin dataset, we are having output variable of 3. Three categories are there. So now how many number of neurons you have to consider for that dataset means 3 as the neurons you have to consider. Fixed every time. For diabetic dataset is there. One is sufficient. For mushroom dataset, 1 is sufficient. Output neuron 1 is sufficient. Okay. For all regression algorithms, 1 only. Fix. Now the number of hidden neurons. Number of hidden neurons in hidden layer. Number of hidden neurons in hidden layer. In the hidden layer, how many neurons we have to consider means, which is equal to no rule. There is no rule. Only the maximum is 2 into number of input minus 1. This is the maximum. Maximum only there is fixed, but minimum there is no rule. You can take 1 to maximum of this one. So it is minimum 1 to this is minimum value. Okay, if you are considering the hidden layer, minimum one neuron should be there now. Otherwise, layer only will not be there. Layer will not be there. If you are considering 0 means layer is not there. Minimum of 1 to maximum is 2 into number of input minus 1. That is the maximum upper limit. Is that clear, guys? Now, let us take one example and let us understand how to design the neural network. Design. We'll focus on the design. Later, calculation. Okay, design is different, calculation is different. Both are different. Okay, here in the artificial intelligence, we have to design the things, followed by we have to compile the things. Compile means we have to do the calculations. Both are different. So first, I'm going to start with the design. For example, I'm having a example called as TV, radio, newspaper says. Example number 1. Let us start with the example 1. And now I want to create a perceptron model for this. For this data, perceptron model. Perceptron model, what is the meaning of perceptron? Means hidden layer is equal to 0. There should not be any hidden layer. Only input layer and output layer should be there. Now in the input layer, how many number of neurons I have to take? 3 neurons. 1, 2, and 3. This one is called as input layer. For this data set, input layer. For this data set, not every time 3. For this data set, it is 3. And output layer. Next, move on to the output layer. Output layer, how many neurons I have to take? Because it is a regression project, only 1. And directly connect between them. Perceptron model completed. Design is completed. Okay. Example number 1. Write in the notes. Take one data set like this. TV, radio, newspaper. This is example 1. And for that, if you are applying the perceptron model, this is the design. Where you are not having any hidden layer. No hidden layer is there. Directly input layer and output layer. Satisfied whatever I have told you earlier? Perceptron model means no hidden layer should be there. Yes, there is no hidden layer. Only one input layer should be there. Only one is there. One output layer, only one is there. How many number of input neurons should be there? Means equal to number of input variables, equal. And how many number of output neurons should be there? Means if it is a regression or binary classification, only one. Satisfied, every point is satisfied here. Done. Now for the same data set, I want to create a neural network, not the perceptron. I want to create a neural network. Then how I am going to design? That is example number 2. For the same data set I am not going to change. Data set is fixed and I am going to create a neural network. Right? So let us see. So for the same thing, I'm going to create a neural network. What I have told you neural network means either hidden layer should be 1 or 2. Choice is yours. You have to decide. Sir, how many I have to decide? That is your requirement. As per your requirement, you tell me how many I have to consider, either 1 or 2, any one. Sir, okay, here you are asking us, but in the coding, how we have to take means for loop, grid set CV. Both 1, you have to apply 2. It will only apply first 1 followed by 2. It will do both of them. You have to take the grid set CV. In the grid set CV, just to give the values with respect to 1 and 2. It will only apply. Right? Now here, again, input layer. Input layer, how many input layers should be there? Every time it is 1 only. Whether it is a perceptron model, whether it is a deep neural network model, whether it is a normal neural network model also, input layer is only 1. 1 input layer. No change in the input layer. Only 1. How many neurons should be there in the input layer? 3. Okay, fix. Input layer completed. Now coming to the output layer. Let us move on to the output layer. How many output layers should be there? Only 1 output layer should be there. Only 1. And how many neurons should I take? Only 1 neuron. Fix. Up to here it is fixed. Now in between, now I'm going to select a neural network with 2 hidden layers I'm writing like this, a 2 hidden layers with each hidden layer of 3 neurons, 3 or 4 neurons, 2 hidden layers, each of them of 4 hidden layer neurons. What is the maximum I can go? What is the maximum number of neurons I can select? 2 into 3 minus 1, that is 5. That is the maximum. Okay, in every hidden layer, maximum I can go with the 5. So first hidden layer, I'm going to take 4. 1, 2, 3, 4. Second hidden layer, 1, 2, 3, 4. Sir, it is mandatory that both of them should have the same number of neurons? No, I didn't tell that rule now. I didn't tell means there is no rule like that. So you can select as per your choice. For example, I'm collecting the same number of neurons. So this one should be connected to this, 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 connected, 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 connected. Followed by this one, this one, this one, this one. Every neuron should be connected to the every neuron. Like this. This is the design. A neural network consists of 2 hidden layers with 4 neurons each. This is the design. Is that clear, guys? This is example number 2. Now let us go with the example number 3. Now I'm having with respect to diabetic data set. In the logistic regression, we have worked on the diabetic data set. For diabetic data set, let us assume I'm having 9 input variables. I don't remember exactly what example in a flow I'm saying. For example, let us assume 9. Now what we have to do in that case? One input layer only, but total number of neurons should be 9, equal to 9. Output one output layer only. In that, how many neurons? Again, 1. Why? Because diabetic data set is a binary classification problem. Since it is a binary classification, again, you are going to apply 1. And if you connect directly, then it is called as perceptron model. If you take in between hidden layers, then it is called as neural network. Now here, if you take this example, what is this example is called as? Where in the input layer, 1 input layer only is there, where I'm having the 4 neurons. 4 input variables are there. Output variable is only 1. And here I'm having multiple hidden layers. How many hidden layers are there? 6 hidden layers are there. What is this example for? This example is for deep neural network example. Okay, what is this example for? One more, this is one example, and here one more example. This example is for neural network. That is deep neural network. This is neural network. Right? Again, in this common thing is input layers are 1 and only 1. Input layer in that example or in this example, 1 input layer only is there. Output layer also 1 only is there. Only the hidden layers has been increased. In between the layers has been increased. Right? Is the point is clear, guys? Now, here we are going to understand first what is meant by neuron, followed by activation function, how these neural networks works, how they will learn those things, and which algorithm it is going to apply means gradient descent algorithm. Similarly, how we are having the OLS technique there, here it is applying the gradient descent. And there is one problem in the gradient descent, and that one was overcome by the stochastic gradient descent. And what is meant by back propagation. All these things we have to understand. Then only we can understand how the neural networks will understand the data. How your missions in the Robo movie, first Robo, not Robo 2.0, first one. Okay, in the first one, where the Vasikar will design, Dr. Vasikaran has designed the Robo Chitti. The Chitti will learn by learning the books now. It will take one book after one book like this, it will learn, right? Even the telephone directory also it will learn, right? How it is going to learn that one? What happens internally? That is the thing which we are going to see. Okay. Now, of course, I'm not going to play the Robo movie. Just we are going to observe the things, internal things only, right? A neuron where we are having the biological neuron. where the biological neuron will collect the information and it will process the information. Every neuron in our body, whatever the neuron is there, every neuron will be like this, where it will collect the information from other neurons. All the neurons are connected, multiple neurons will be connected now. So from the multiple neurons, it is taking the information. In the neural network also, for example, I'm drawing like this. This is my hidden layer neuron. Now this one, this is the hidden layer neuron, first one. This one is collecting the information from here. It is collecting the information from here. It is collecting the information from here. From 3 different sources, it is collecting the information. And here it is processing something. Internally, it is doing the processing. Here, how many neurons it is collecting the information is with respect to from 3. So now just observe this diagram. In this diagram, from how many it is collecting the information? This one is collecting the information from 4 of them, and it is passing the information to 6 of them. This single neuron, it is collecting information from 4 inputs are there, and that output, whatever the output it has given, the output from that neuron, it is sending that information to remaining 6 neurons, whatever connected to the next one. This neuron, it is collecting the information from 5 of them, and it is sending to the 5 of them. Sorry, not 6, 5. Okay. So it is collecting the information from 4. It is sending the information to 5. Now this one, it is collecting the information from 4 of them. Finally, it is going the final output. From this, whatever the output you are getting, that is the final output. That is the answer. That is the answer. Okay. Here, nothing is connected furtherly, miss. This is the final one. Final one miss final output. Always the output layer will be in the end. If something you connected here, then it is considered as hidden layer. From there, no connections should be there. Directly the output only will be there. The answer will be there. In the output layer, only directly the answer you will get. Right? In the input, it is going to send the information. Whatever the data is in the tabular data, that information will be sent into this, and it will process. Now, once it is processing this one, now here in the normal in the body, it is collecting the information from various. For example, you are seeing at the board, your eyes are collecting the information. I am speaking, your ears are collecting the information. Eyes and ears, both the informations are sending to the brain. From your eyes, whatever you have collected. In meanwhile, you are discussing with your friend, he will say something now. That one also you are going to listen. That one you are listening, whatever I'm saying listening, and whatever you are observing on the board, you are listening. And in meanwhile, if you are turning the pages to linear regression backside, that one also you are observing. From various sources you are observing, and finally you are sending into the brain. You are sending that one. So here, multiple input neurons, they are sending the information. Here it is doing the process, and this process is sent to the connected output neurons. This is biological neuron. Biological neuron means where it has the dendrites. Dendrites means connections between the input neurons. Neuron means where it will do the process. Axon means passing the information. Starting dendrites will be there, ending also dendrites will be there. Connections will be there. These dendrites only in our case, the lines like this. Whatever we are drawing the lines now, connecting them now, the lines are nothing but dendrites. We are drawing like that. Right? Now, here, next, the neuron, whatever the neuron is there, it is collecting the information from the input, and it is going to do the process. Okay, collecting the information from this. Collecting the information is called as synapse. Okay, and it is going to process this information. Now, whatever the information it is going to process, as already I have told you, the output variable, if you are having only continuous means single neuron. If you are having binary classification, also single neuron. But if you are having multi-class classification means according to the multi-class. If you are having more than 2 classes in the output variable, accordingly, you have to take the output layer, neurons. Now, so here you are having with respect to each connection is assigned with the weight. Every connection will be assigned with the weight. Now, every weight after assigning, now in this, it is going to do the process. What process it is going to do? What it is going to do internally? The process it is going to do is called as sigma WI xi plus B. sigma wi xi plus b. Sir, can you explain this concept in a simple way? Okay, let us see this example. Whatever the example I'm having in the starting, this example. So here, this neuron was connected to this one. This is x1, this is x2, and this is x3. Here I'm having different arrows, different connections are there. How many connections are there means 3 into 4, total 12 connections will be there. Every neuron will be connected. So this will have 4 connections, this will have 4 connections, this will have 4 connections. So 3 into 4, 12 connections will be there. Now here, this is W1, W2, W3, W4, W5, W6, W7, W8. Like this, if you write everything, for example, for this one, for this neuron, I'm writing here W1, W2, and for this weight, I'm going to give the W3. Assume I have given the weight like this. Now, this particular neuron, W1 is connected to the X1, W2 is connected to the X2, W3 is connected to the X3. So now what is the equation means? W1 X1 plus W2 X2 plus W3 X3 plus B. It is going to do internally this one. Sir, W1 is randomly I'm going to assign the values. X is input data. What are the input data? Tabular data is there now, data frame. That data frame, the values are there, right? Inside that one, that values are X1, X1, X2, X3. For example, let us take like this. I'm opening this SAYS data set. Whatever I have worked on the regression first data set, that is advertising data set. For this data set, the first record 2,30,100 is there. That is X1. 37,800 is X2. 69,200 is X3. So here it is going to take this one. Where is this? 2,30,100, 37,800 and 69,400 something. Now here W1, W2 and W3. So now it is going to process some value. You are going to randomly assign the values. How we are going to assign? There is fixed formulas are there. Okay, I will explain later. Okay, how to assign the random values, or now itself I will explain. How to initialize the weights means the weights are initialized. The weights are initialized. Initialized means first initialize means starting one. Later it will do the modifications. Later it will do the trial and error. First value you have to initialize now. The first value will be initialized between -1 by square root of input 2 plus 1 by square root of input neurons. That is, it is going to take between -1 by square root of 3 to plus 1 by square root of 3. It is going to take randomly 3 values. And that too, the 3 values will form the uniform distribution. The 3 values will form the uniform distribution. It is going to select randomly 3 values. The 3 values it is going to select from minus. Sir, why it is going to select 3 values only? Because 3 input neurons only are there now. 3 weights you want. So what? Sorry, how many weights are there here? Total 3 into 4, 12 weights are there. So it is going to select the 12 weights. Total 12 weights will be selected between -1 by square root of 3 to plus 1 by square root of 3. Every weight, whatever the weights are there, every weight will be selected between this one only. Sir, for example, you are having 4 input neurons. Then let us take like this. Okay, let us go with this example. In this case, how many connections are there in between? Between this one and this one, how many connections are there? 3 into 5, 15 connections are there. So it is going to select the 15 values between -1 by square root of 4 to plus 1 by square root of 4. Sorry, 4 into 5, 20 now. Sorry. Correct. 4 into 5, 20. 20 values it is going to select between -1 by square root of 4 to plus 1 by square root of 4. Initialization only. Later, adjustment will be done. Adjustment will be done later. Initial one will be started here. Got the point? So this is called as weight initialization. Weight initialization with respect to uniform. Uniform means it is going to take the values which form the uniform distribution. These 20 values will form the uniform distribution between them. If you make a histogram, the histogram between all the 20 values will be like this. The histogram between the 20 values, if you draw the histogram will be uniform. Okay, means between minus 1 by square root of 4. What is meant by 1 by square root of 4? Minus 1 by 2. 2 plus 1 by 2. So in between, you are going to select 20 values. For example, let us take like this. I'm taking the 10 values from minus 1 by 2 to 0, 10 values. 10 values I'm going to select from 0 to 1 by 2. 10 values between this one, 10 values between this one. Is that clear? So that it is having the same number of weights, uniform distribution it is maintaining. In that way, initial weights will be analyzed. It will be given. Is that clear, guys? Once the initial weights are given, now it is going to calculate the sigma wi xi plus b. Now, what is meant by sigma? Sigma means nothing but w1 x1. Can I write w1 x1 plus w2 x2? Can I write like this? Sigma I is equal to 1 to 2 wi xi is both are same. If I take w3 x3, can I take up to 3? Similarly, so on up to wn xn. Can I write here n? Right? So whatever the equation we are having in the multiple linear regression, that is beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus so on up to beta n xn, whatever we are having, can I write the same thing like this? Sigma of beta x, beta I xi. Can I write like this? Sigma means nothing but summation. Now, from where it is starting? What is the beta value starting? 1. I is equal to 1 it should start. Where it is going to end? N. It is going to end here. Can I write like this? Same thing here in my case, w1 x1 plus w2 x2 plus w3 x3 and so on up to wn xn. Same thing I'm going to write sigma I is equal to 1 to n wi xi. Wherever the word w is there, w means beta in machine learning. Here it is w, fix. Wherever the b is there, wherever you are having with respect to b, wherever the b word is there is equal to beta naught in the machine learning. W means beta 1, beta 2, beta 3 like this, that is slope, or which is also called as coefficient. Here it is called as weight. Okay. Coefficient in machine learning is equal to weight in the artificial intelligence. Intercept is equal to here bias, which is b. W and b. Here we have taken beta 1, beta 2 like this, and we have taken this one as beta naught. This is beta 1, beta 2, beta 3 like this we have taken here. Here we are writing W1, W2, W3. We are writing W1, W2, W3 like this. Both are same. Right, guys? So that is the end of the session for today, and we'll continue with the tomorrow's class. Tomorrow we'll complete the entire processing of the artificial intelligence, and just to go through whatever we have discussed till now. And along with this, please check your linear regression and logistic regression. Go with the theoretical part of your linear regression and logistic regression so that the class will be easy to understand. Okay. If you understand that theoretical part, once you recollect your theoretical part of not the coding part, what will be there? Import and fit. What is there in the coding? So don't observe the coding. Coding is not important. Okay. In the coding, you will not understand the subject. You can apply only, but you will not understand. So go to the theoretical part of linear regression and along with the logistic regression theoretical part, so that now this theory will be clear. Right? And we'll continue with the tomorrow's class. Sir, Sir, in future class, will you be teaching Hadoop and MapReduce and Spark? That is not included in the syllabus copyright. Whichever is included in the syllabus, whatever I have given in the starting in the demo session, the same thing will be included. Whichever is not in the syllabus copy, it will not be included. Right? Done. Yeah, Shubham. Sorry, Shubham. I have forgot to upload that one. And today, surely I'm going to upload that one. 100% I will upload because due to some reason I was not able to upload in the last. So today I will upload. 100% I'll upload. Okay, I have seen your mail also. Thanks for the reminder. Today I will upload. Okay.